today, and we will finish today as well. It's kind of very short chapter or module that we can cover within the next 1 hour or so. So the discussion today will be about a very, very, very hot topic. One of the hottest topic in surveying. It is called laser scanner. Laser scanner. So the laser scanner, it has a little bit of history. I'm gonna, as usual, I'll kind of show you a little bit of development on the laser scanner side. Also, we talk about how does the laser scanner operate, like what is the basic idea. We talk about one important topic, which is some called the point cloud registration, which I know that by now nobody of you guys know that what does it mean. What does it mean point cloud registration? So we'll explain for you what does it mean and how we can do it. We will also in this class talk about LiDAR systems like airborne laser system that is carried in a moving platform like an aircraft, and we will see how this system differs from ground-based system. And then finally, I guess after I finish this session, probably you will have a big question in your head asking you, oh, you taught us something called photogrammetry, which is, you said, amazing, and it creates a very dense representation of the object with color information. Today, we're creating almost the same product. So, Tahir, which one do you recommend? Which one is the best? Is any one of those techniques better than the other, and in what sense? So, this question will be answered at the very, very end of our class today. Okay, let's get started. So just kind of, if you follow this discussion, great. If you don't follow it, it's fine by me. I just want to remind you what laser stands for. So laser is not an English word. Although we use it right now as an English word, like so many things, like GPS or GNSS, while laser stands for like a short for terminologies, okay? So laser, which is again, this is kind of borrowed from physics. I myself study about laser back in high school physics, but laser is light amplification by stimulated emission of radiation. And I know it looks very complicated. It looks very complicated. And nobody right now say light amplification. Everyone is saying laser, laser, laser. But this is how the word started. Okay. So it is simply a device where you apply some energy on some material, and the material, it has atoms and molecules, and those atoms will be stimulated by the amount of energy you add to them until the point where they start emitting some sort of radiation, which is electromagnetic wave. And simply the power or the amplitude of the electromagnetic wave is kind of amplified, okay? And the it creates kind of a electromagnetic wave in some band. We talked in my class here, probably it was annoying for you, I guess, in photogrammetry. When we talked about satellite photogrammetry, we talked about electromagnetic waves, and we said all of them, they have the same speed, but they vary in nature depending on the frequency and the wavelength. If you remember this silly discussion, okay? So when we stimulate those molecules and atoms, what they do is radiate in a different bands. So some of them, they are visible light, some of them, they're infrared, or even sometimes it's ultraviolet. And because you can see we have variation in the nature of the wavelength, we also get variation in the characteristics of the signal, okay? Now, here is really, if you don't get like what I said before, that's totally fine. Here is what I want you to know. The how the EGM, and EGM probably is not a good a new name for you, huh? EGM. You've heard the word EGM last year on your first year surveying course, and you have heard this name one more time early in my class when we talked about total station. Because total station, one of the measurement of the total station is distance. We measure distance electronically by means of EGM. And how it works is the EGM will simply emit a signal. The signal will travel all the way until it hits your object. reflected back to the device, where the device can measure the time of travel back and forth. And by knowing the velocity of the signal, we can simply estimate the distance, same as the equation you see on my screen. Distance equal velocity multiplied by the time of travel. Now, since we said we have several different signal of the laser, so you can see here there are some, the ADM also will be classified in different categories. One is working by using microwave instrument or microwave, and another one it's working by using infrared, and the last one is working by using visible light. What makes one EDM different from the other is simply the range. So the range will be different. For example, the microwave, you can measure a distance up to 100 kilometers with accuracy of plus or minus 5 to 15 millimeter per kilometer. Okay. You know what? I really focus on the red one, the one I highlighted with red, because those are the ones that we use in total station. In total station, we don't really measure 100 kilometers. We do not measure 100 kilometers. We measure distance within few kilometers, so we are okay with using infrared. So the range will be between 3 to 5 kilometers, and the error will be plus or minus 10 millimeter for every kilometer you measure. Is it amazing to measure 1 kilometer, 1,000 meter, and your error will be plus or minus 10 millimeter? What do you think? Is that good or bad? Any help? Any thoughts of if I make an error of plus or minus 10 millimeter every time I measure distance of 1 kilometer? Is that good or bad? What do you think?
Looks good.
That is amazing. That's amazing. You guys, I mean, because you just lived in the new era of total station and surveying. But you know what? People, they are making maps for hundreds of years, even before the invention of those total station. So how people used to measure a distance before total station, they use chains and measure tape. More accurate one, that the one that we use in home for home improvement project, but it's same idea. It is something that has a tape that you can simply stretch and you can take your reading. And you know what? Without going into details, the use of measure tape or chains, it is just calling for error and trouble. Okay, because it's very difficult to measure a distance which is maybe 3 or 4 times the length of your chain. If because simply if I ask you to measure, I give you a measure tape, which is, let's say, 5 meter, and I ask you to measure your room, the dimensions of your room. That is really piece of cake, okay? Because you're gonna put a zero in one end, you're gonna extend the other side, you can take reading easy. The problem is, in reality, between the points, there is no straight wall that you can align your measure tape with. Although there are so many things that will make it the process even more difficult. For example, what if I have a fence? What if I have trees? What if I have, a lake in between the 2 points? So this will be amazingly, troublesome. Okay, so that's why those total station, they are a great invention. They simply save surveyor a lot of effort and make the measurement more accurate. Okay, I'm good for now. I'm gonna move on to the next slide, which is let's start with ground-based laser scanners. So ground-based laser scanner, those ones, I want everyone to look at the name because this is very important, huh? Ground-based. It means they sit on the ground and they operate in a static mode, which means you set them on top of a tripod, you allow them to scan the scene, and then yes, you can move them to another point, but after you finish your first scene. So we have here, I included on my slides two different laser scanner, and those scanners are available at SATE. So if we are normal time, probably I could bring one of them to the class. One is called Leica B20, which is kind of old laser scanner, and one of the newest product is called Leica BLK 360. I'm gonna give you some prices, but don't get too excited, huh? So the price of the one on the right, probably it's above $100,000. The one on the right, more than $100,000 for the time we purchased this in Said. Very expensive piece of equipment. And I wanna, make some remarks here, because simply laser scanner, it was probably around in the market from late 90s, let's say, to make it simple, year 2000. Okay, so which means they have been in the market for 20 years. And if you remember my discussion when I talk about photogrammetry, I said photogrammetry is there probably for 200 years since the invention of camera. And it was kind of cornered to one application, which is large scale mapping. But you know what happens for the last 20 years, huh? There is improvement in blah, blah, all what I said in photogrammetry. But guess what happens? When laser scanner they came out, photogrammetry was so weak, huh? Because we still starting to see the improvement in the algorithm and the automation of the process. So that time, 20 years ago, laser scanner was so popular and so hot topic. Everyone wants to have a laser scanner because it's so productive and it gives you a fantastic product. And then what happened is photogrammetry start to take over. Okay, take over because simply we have better algorithm, we have digital cameras, we blah blah blah, all of what I said in photogrammetry. So this makes photogrammetry is more cheaper option to create a 3D point cloud. So laser scanner kind of a slow down until recently, and it's a fight, by the way, it's a game, it's a big fight between photogrammetry and laser scanner. So recently, laser scanner manufacturer, they try to put some effort to reduce the price to be competitive with photogrammetry. So what happens right now? We have the one on the left. So on the one on the left, which we have a video for it, and I think you will enjoy the one on the left. If you see the video, you will just love it, fall in love with the one on the left. This is a very tiny compact laser scanner with a price of only $20,000. Okay, we will see a video. Okay, and I will tell you a story about myself with this scanner, a couple of years ago. But really, what I wanted to discuss in this slide is the change of the price. The sensor went from a very bulky, heavy, pricey equipment into a very compact, very affordable price. And I will even go further to tell you, I have a news for you, but not now. Once we discuss the BLK, I will show you what is happening in 2021 right now. Okay, so let's move on to my next slide, which is I'm gonna let somebody right now to teach you something. I found those people, they are better than me in teaching, so I will let them teach you something. So I'm grabbing here a couple of videos from YouTube. They are by Leica, and I'm not sure if you know about Leica. Anyone knows about Leica or heard this name before? Leica. So Leica is a monster company that simply manufactures all surveying equipment, including GPS, total station, cameras, levels, everything you can imagine. It created by Leica, and Leica has some educational videos on YouTube. So I kind of picked two of them to teach you about laser scanner. So let's watch the video. And the video, although they are trying to, for example, advertise for their product, which their product for sure is amazing, but also it contains a lot of useful information for you guys in my class. So let's go ahead and watch the video, and then we have a discussion.
Hi, I'm Alex.
And I'm Lori.
So you're interested in laser scanning?
Or, as we at Leica call it, high-definition surveying, HDS.
Right, and as the industry leader, we're delighted to tell you about it. First off, laser scanning is simply a method of high-accuracy mapping.
Or reality capture.
Right, Lori. However, unlike methods that only capture specific individual points, one at a time, a scanner quickly captures rich detail of the entire scene. It's like a camera taking a 360-degree photo, but with an accurate position for every pixel.
So someone might ask, what's good about that?
Well, one obvious benefit is getting better as-built or existing conditions information sooner. For design and construction projects, that translates into reduced risks and reduced costs.
And fewer sleepless nights. And topographic surveys are so detailed and so complete, you'll rarely have to go back for more field work, even if something wasn't defined in the original scope.
And you can do them faster, too.
Monitoring surveys?
More comprehensive.
Volumetric surveys?
You can do them faster, too, and get more accurate results. And, oh yeah, there's no need to walk on hazardous piles.
Same for roadway surveys?
No need to stand in the road.
What about for forensic investigations and event pre-planning?
You can virtually revisit a scanned scene on your computer anytime for more measurements and verify what witnesses could or couldn't see. And because laser scan data is digital, you can use it with many types of software. For example, you can review proposed CAD designs in their real-world context.
Wow, those are some terrific benefits, Alex. But most importantly, you can save yourself, your clients, and even your clients' clients a lot of time and money.
And in the process, improve your business with higher revenues and profits, new clients, and happier clients.
Wow, that's impressive. Okay, so how does laser scanning or high-definition surveying work?
Well, there are two basic parts to it. First, there's the field work, where the scanner captures the scene. Second is the office part. There, the field data is converted into the products and deliverables that you need. In the field, you simply position the scanner so it can see and reach what you want, push a button, and let the scanner do all of the work.
What about photos?
The scanning process includes taking panoramic photos, if you want, for even more realism.
What about capturing an entire site?
You simply move the scanner to different vantage points for more scanning. Multiple scans are then stitched or registered together, either as you scan or later on.
Scans can also be accurately georeferenced to coordinate systems, just like a standard survey. In the office, our scan software enables users to efficiently create an endless variety of deliverables, from the simplest ones like 2D plans and elevations, user-friendly panoramic images with measurements instantly available from each pixel, clearances, point-to-point and point-to-surface measurements, high and low points and tie points, sections and profiles, volumetric reports, line of sight and crime scene witness viewpoints, and bullet trajectory analysis.
Our software also lets you create more advanced deliverables, like detailed topographic maps, wireframe and surface models, ISO packs, links to asset information, fully textured models, fly-throughs, fully intelligent plant models, or building information models, or BIM, all by using our software. So basically, that's how it works.
One final question. What options do users have to take advantage of scanning?
Well, there are three popular options. First, you can buy a...
So I had to stop the video here is because the remaining part is just like, advertising for their services, which you guys are not to make use of it. So that's why I'm going to stop the video here. However, before I run any discussion, what I will do is I will just run the other video for you from their website, sorry, from YouTube, and we will have a discussion after. So let's watch the second video and then we have a discussion.
Hi, I'm Alex.
And I'm Lori. As the market leader in laser scanning, Leica Geosystems is uniquely positioned to further educate you about how it all works and how we can help you succeed. In this Chapter 2 video, we'll look closer at the field work, the office part, and our outstanding support team. Let's start with the field work, Alex.
Right. There are different types of scanners, but they all work on the same basic principle. The technology is advanced, but it's designed to be easy to use. A laser scanner emits a rapidly pulsing or continuous laser beam. As it emits the beam, the scanner automatically rotates around its vertical axis, and a rapidly spinning or oscillating mirror also moves the beam up and down. The result is a systematic sweeping of the beam over the area. When the beam hits an object, some of its energy bounces back to the scanner, where if the returned energy signal is strong enough, a sensor detects it, and a timer uses it to calculate the distance from the scanner to the object.
But there's more to 3D scanning than just measuring distances, isn't there?
Yes, for each distance measurement, additional critical data is recorded, including the corresponding horizontal angle of the rotating laser and the corresponding vertical angle of the moving mirror. The scanner automatically combines these to calculate a 3D X, Y, and Z coordinate position for each point. The resulting scan is a set of 3D coordinate measurements.
It's a detailed 3D representation of the scene, often called a point cloud.
And to add realistic texture or color to scans, matching photos can be taken.
Can you tell us how that's done?
Sure. Using either a camera that's built into the scanner or using an external camera and automatically merging the photos with scan data. Scans can also be easily geo-referenced to local coordinate systems, just like conventional surveys.
Now, what if you need to capture an entire scene where some views may be obstructed, or if a site is so big that the scanner can't reach all of it with one scan?
Right. In those cases, which are very typical, the scanner is moved to different vantage points for more scans. The best vantage points will be based on site logistics and scanner capabilities. Multiple scans can be automatically aligned with each other.
Can you help us understand how that's done?
Well, if the scanner is properly equipped, this registration step can be done right on board the scanner. Otherwise, you can do this later by post-processing the set of scans. In fact, users have several convenient options for post-processing.
I thought that might be coming.
Some methods use handy scan targets or markers placed around the site. Other methods don't need any targets. Regardless of which method is used, it's important that it be done accurately.
The good news is that Leica scanners and software have all the right features that let you do it with confidence, whether it's a simple scene or a complex one. But doesn't a registered point cloud contain hundreds of thousands or even millions of points?
Or even billions of points.
Yes, and here's where your office software comes in. It lets users mine this rich information for an almost infinite variety of applications and deliverables, from simple ones like 2D plans and elevations, user-friendly panoramic images with geometric information instantly available from each pixel, clearances, point-to-point and point-to-surface measurements, high and low points and tie points, sections and profiles, volumetric reports, line of sight and witness viewpoints, and bullet trajectory analysis.
And you can also create more advanced products and deliverables like detailed topographic maps, wireframe and surface models, ISO packs, links to asset information, fully textured models.
So I'm gonna stop in here because simply this overlaps with the other video. I don't want to, spend more time on this video. However, really before we proceed, just wanna, the two videos, although they are probably in total will be about 25 minutes or so, but they carry a lot of useful information. I'm just gonna point out a few of them because I know that they go quickly through the information, and probably I can ask you a question. Do you guys, if I ask you, does the laser scanner operate differently from a total station?
I don't think so. It just captures more points.
Exactly. So really, to my view, just the laser scanner is a total station, so has no more measurement than a horizontal direction with a vertical angle, with a slope distance to where you want to find the XYZ. The difference is total station picks a very, very specific point where you need to place a target or a prism, or you can use the total station in reflectorless mode to find the XYZ, while laser scanner probably it has a stronger signal, so it works always in reflectorless mode. However, it simply continues the process continuously. What does it mean? It means the scanner mirror will oscillate and the whole device will rotate. So at the end, it will give you kind of a scan, not specific point like discrete point, rather than a point cloud around where you are. And everything is referenced to where was your laser scanner. So all the coordinates comes with reference to where was, let's say where I was is 0, 0, 0. So everything comes with respect to my 0, 0, 0. Okay. So that's one thing I wanted everyone to understand and recognize, that a laser scanner is pretty much, the theory is, and uses exactly the same set of equation that we went through in the beginning of the semester, but it just continuous scan, not a specific point. And that's why it's not selective. Like, for example, if my client asks me to survey the manholes and I'm using total station, I will be surveying only manholes. However, if you use laser scanner, it doesn't really pick the manholes only, but it simply measures everything within the vicinity of your laser scanner point or location, which is simply, as again, as that's make a huge difference between a total station and laser scanner. Okay, but again, they use the same math. So that's one thing. The other thing I want you to remember is that the application of laser scanner, to be honest, there are so many applications for us in civil engineering. We can do topographic mapping, which can yield to cross sections and profile, stuff like that, just like total station. And we can do things that needs a rapid survey. For example, like crime scene and simply accident investigation. So you can bring your laser scanner in a matter of 5 minutes. You have a 3-dimensional survey of the area where you can simply open the scene for traffic, and then you can do your investigation later on. Again, there are so many applications goes into gaming and virtual reality. Again, that's not really my scope in my class, but the applications are so many. One more thing, I'm not sure if you got already from the video, is that a laser scanner can give you only X, Y, Z, like 3-dimensional information. That is unlike photogrammetry, where the photogrammetry by nature, it gives you X, Y, Z in addition to color information. So at the end, you get colorful 3D model colored with the real texture of the reality. In laser scanner in 2021, all the new scanners, they come with a built-in camera. So as the scanner gives you a 3D scan, the camera will also capture some photos, and then it is a matter of processing where you can simply take every XYZ, and you can go to the image, take the color information, and go back and paintbrush every point with the color from the image. But remember, this is not done by the laser scanner. It is done because we have camera that captures color images. Again, there are more information in the video. You know what? Probably this is what I can remember, but I'm just going to ask you guys, when you review your for maybe for the midterm exam, for the assignment number 5, or maybe for the final exam, this video is part of the material, so you need to watch the video one more time. Okay. Now, again, this is nothing new. What you see on this screen is that this is the main idea of laser scanner, where there is a continuous emission of pulses or laser pulses that goes into different direction in space because of the rotation of the mirror and because of the rotation of the laser scanner around the vertical axis. And this primarily will give you a 360-degree scan. Now, here are some of the specifications of the Leica BLK 360. So it gives you the range. For example, for 360, it can survey within 60-meter radius. Okay. The weight is 1 kilogram. The size is so tiny. It's just like very tiny, very compact. The diameter is 4 inches, and the height is about less than 7 inches. And the accuracy is plus or minus 6 millimeter at 10-meter range. And so those are some specifications to give you a feeling of what this scanner can give for you. And for example, the speed of the capture, it captures 360,000 per point. 360,000 points per second. Can you imagine if your scan is 3 minutes, for example, for a 360 degrees? Can you imagine how many points you end up with? Millions and millions of points, which gives you a very high accurate representation of the ground. So there are so many points on the object. I think I would go through this, and probably we can. I think we have time to go for. Yeah, I mean, I'm gonna go for this one first, which is about registration. So if you guys remember in the video, they were talking about, okay, what if my site is big? Or what if my site has so many objects where there are some area would be occluded? What can we do in this case? Probably you guys figure it out. It looks like one location of my laser scanner would be sufficient. Looks like I have to move my laser scanner from one point to another point. Would you agree?
Yes.
Okay, so and then what when we move the scanner between several setup for the scanner, what happens here? So every scan location will give you a point cloud, and this point cloud has its own coordinate system. As I said before, all the point, all the XYZ will come with reference to where is my scanner. Let's assume that every time the scanner will work, we'll assume that its location is 0, 0, 0. So all the points will come with respect to this 0, 0, 0. And what does it mean? It means if I have 4 different scans, like I move my scanner 4 times, it means I will get 4 different point clouds, and each one of those, it follows a different coordinate system. Is that good or bad? Can I ask you? If I have a 4-point cloud, like million point here, million point here, million point there, million point there, but every million point, they follow different coordinate system. Good or bad?
Bad.
Okay, so how can we solve this puzzle? We want all my site in one coordinate system. So at least I can measure the relative location in a right way. Otherwise, you cannot get relative information because every point is not every point. Every scan has its own coordinate system. So really, the answer is very simple. All you have to do is do something called registration, point cloud registration, sometimes called stitching. So we want to bring and move all these point clouds to align to each other, okay? And how we do it is there are several ways. First way, which is the oldest one, which I don't think it exists until now, it's kind of manual. So a user will sit down and will take one point cloud and slowly move it, rotate it until it fits next to the other point cloud. And remember, always the fitting or the stitching or the registration always happening on the overlap area. So the overlap area, it's what tells you that you are well aligned. Okay. Number 2, we used targets. You can see even in the video, there was some reference to those targets. And in my slide here, I'm showing you some of these targets. For example, the one in the middle has a like white ball, and the left and right looks like very much like total station targets. And those, if they show in 2 different scan, can you guess what happens? I can use these points to register. It means move one scan until these points that they show in 2 different scan align. Finally, what we have in 2021, the software becomes so smart that can identify the common area and can do automatic registration. Just find where is my common area, and then it will simply move and rotate your second scan until it fits into your first scan. You will see this very clearly in the next video, okay? So the next video, I'm going to show you the next video, and then we have a break, okay? So the next video will talk about BLK 360, which you will see how amazing to use this one. And let's watch the video, and I have a very nice story for you to tell you, okay? Then let's watch the video.
My name is Jeff Bowers. I am with Imagine Technologies, and I am the Reality Capture Technical Manager. And what we thought we would do today is spend a little bit of time getting to know the BLK. We're going to give you some ins, the outs of what this unit can do. What we're going to do for a few minutes is take the equipment, assemble it together to start the process so we can start scanning. First thing we did was we've got our tripod. We have decided at Imagine Technologies to use a taller, more adjustable tripod. We went with the ProMaster XC525. It's extendable. And you're going to notice that I already have our BLK adapter attached to the tripod. What we want to do is go ahead and very securely hold our case and start pulling our unit out. Now that we've got our unit out, what we want to do is we're going to press both buttons on either side of the BLK adapter. Go ahead and lock it on here. Before you let go, be mindful, be very careful. We want to make sure that the tripod legs are fastened or locked into place. And also, we want to be able to make sure that the unit is securely attached to the adapter. Then we can let go. Now we're ready to scan. So what we're going to do now is take the BLK, go ahead and move it into our first position, get it set up so that we can start the first scan. I've got it set up now. I am going to go ahead and make sure that the legs are nice and secure. To turn this unit on, I simply hold it in the back. I have a power button here. I'm going to press and hold that power button down for about a second. You're going to notice the lights kick on. Now I'm going to grab my iPad so that we can start scanning. What we want to do is go ahead and click on our settings, and using our Wi-Fi connection, I want to make sure that the scanner and the unit are connected together. Click on our settings, look at our Wi-Fi, and we're going to ensure that the BLK is connected using the Wi-Fi signal. I'm now going to hit home, and now I'm going to come over here and I'm going to use the Autodesk Recap Pro app. First thing we need to do is come in here and I'm going to choose New Project. Under New Project, I'm going to simply give it a name, and we'll give it the name Sample. I'm going to hit Capture. Now this is going to take me into the screen where I have control over the scanner. Before we do, I want to go in and make sure that some of our settings are set up correctly. Down here at the bottom, I'm going to hit Settings, and I'm going to use In-App Settings. You're going to notice that I have 3 settings, low, medium, and high. For today, we're simply going to use the medium setting. You're going to notice that I have full control over my photos, whether I take photos or not, whether I do HDR or not. Once you've made that decision, I can simply pick into the screen anywhere, and now I just simply need to hit New Scan. Once I hit New Scan, the scanner will now start scanning. Now that I've hit New Scan, you'll see that the scanner is starting. So now that the scan is completed, you're going to notice that the data has been transferred here to our iPad. Please note that the data is still located on the scanner. Looking here, in order to view this data, what I want to do is simply pick on the images. From here, once the images are open, I can now take my finger using my gestures and be able to navigate around to look at the type of data or the quality of the data that was captured with the BLK scanner. So now that the scan is completed, what we're going to do is go ahead and pick up our scanner and we're going to move it to the next location. Once I get to my location, I'm going to set it down, make sure that the legs are still secure. Now I am ready to start the second scan. All I need to do is come in here, hit New Scan, and now it is working. That second scan is finished scanning. What we want to do is you're going to notice that the data has been transferred to the iPad and it has turned red. When it turns red, that is telling me and giving me the indication that it's ready to be registered. You just simply need to pick on the image. You're going to notice that the registration screen comes up. If this registration is the way you want it to be, most of the time it will be. All I need to do is hit Merge Scan. Now those 2 scans have been registered together. Today we spent a little bit of time working with the BLK. If you have any other questions, please feel free to reach out to us at imagineit.com.
Okay, so anyone fell in love with this scanner? You know what? This is just amazing. Like, it takes someone to learn about Total Station, I would say a month or so until he masters how we level it, center it, to know the internal programs and how to input, the occupied station backside. That's a lot of work, a lot of learning. But I'm going to tell you a story, which is a funny story. So 2 years ago, I guess 2 years ago, just before the pandemic, I guess, a capstone team, they were in my surveying class, and they thought, I'm, the surveying guy. So they thought that I know everything. And they asked me, do you know about laser scanner? I said, yes. And he said, we're borrowing BLK from SATE, like a survey crib. Would you help us? Okay, so, okay, for sure, I can do that. So you know what? What I did is just to watch this video, which is, let's say, 5 minutes video, and I became the expert, and I went and I simply started the survey, finished the project. And that is what it takes you to become an expert with this guy here. Amazing. So again, this brings us to the break. I will just ask you if you have any question before we break. Any question?
Yes, Tahir. Is there any limit for the overlapping? They didn't say anything, if it's 10, 20%.
You know what? It's I would say, to be honest, there should be probably, doesn't have to be a specific number. I can tell you it has to be a specific geometry. Like you could have, it doesn't go by overlap because because it needs a surface, huh? Remember, you're trying to move a 3D cloud to fit into 3D cloud. So what if there is only overlap like a floor? Even if you have 100% like overlap in the floor, it doesn't work because simply the floor is only planar surface and you have a freedom, like degree of freedom that you can move without feeling. If you have perpendicular walls, if you have a perpendicular walls like walls and then floors, this will make a really good registration. I'm not sure if you follow what I said, but what I'm saying here, really, yeah, there should be a percentage of overlap, but also it has to do with the orientation of the planes that is common between the scans. If you have a really big overlap while is only one plane, you cannot do good registration. But if you have a floor plus walls in the overlap area, the registration will be a good registration.
Thanks.
But this is a very good question. Thank you. Any other question before we break? Any other questions before we break? Okay, so now it's 12:55, so we'll take 10 minutes a break. We'll come back here at 1:05 sharp. Thank you so much.